In this course, we are going to look at a bunch of circuit elements or circuit components. Okay, and all of those circuit components can be idealized or represented using a basic circuit element. Let me show you what I mean. We are going to look at resistors, capacitors, inductors. These are all circuit elements that we are going to encounter in this course, use extensively. In addition to those, we are going to look at some voltage sources. Some current sources, both dependent and independent current and voltage sources. Okay, so again, this box is a symbol for an independent, a dependent current source or a voltage source, dependent voltage or current sources. So in this case, I'm showing a dependent current source. But the idea is there are a bunch of these circuit elements that we are going to encounter in this course. And then the basic circuit element that I'm going to talk about right now, this is a representative of all of these circuit elements. Okay, and there are three important characters that we are going to define for the basic circuit element. Number one is that it has just two terminals, terminal 1 and terminal 2. So let me name them. Terminal 1 and terminal 2 are the external connections. Okay, so this is the basic circuit element, right? It has two terminals. That's the first property, and it has just two terminals. The second property is that it can be completely defined in terms of its terminal voltages and current. Okay, terminal voltages and current that is flowing through the circuit element. Okay, and the third property, of course, is that this cannot be subdivided into anything else. Resistance is a fundamental property that is basic property of the element. It cannot be expressed as something else, right? So all of these capacitance, inductance, so on and so forth, they're all basic properties of circuit elements, and hence they represent, or in other words, my basic circuit element represents these basic um, different circuit elements that we are going to encounter in this course. Now, what is important, like I mentioned in the previous video, is the sign or polarity. Okay, the relative sign or polarity between the current and voltage, that is important. Let's take a look at this basic circuit element and then identify a certain things. Okay, first thing is there is a positive sign for the voltage on the left side or on terminal 1, and there is a negative sign, right, on the right terminal, terminal number 2. Okay, we like to call this terminal with a positive voltage as high, okay, and the other one as being a lower potential. Okay, the negative terminal or terminal 2 as shown in this diagram is at a lower potential. Okay, now the passive sign convention says whenever the direction of current is from positive to negative, then both the voltage and current are positive. Okay, or in other words, if you were to reverse this polarity of the current, okay, if you were to reverse the direction of the current like so, okay, then it would mean that the current is actually flowing from the negative potential to a positive potential. Then it's a negative sign. We use a negative sign in that context. Okay, otherwise, in our regular scenario, okay, and this is purely a convention, this is something that we arbitrarily assign, and we want to stick with that convention throughout this course. Fundamental: when the current is going from a higher potential to a lower potential, from a positive terminal to a negative terminal, both voltage and current are considered positive. The relationship between V and I is positive. So that's the passive sign convention. Okay? Or in other words, the way I like to remember is current, positive current flows from positive voltage or a high potential to negative voltage or a low potential, from a high potential to a low potential, high voltage to a low voltage. Okay, positive to negative voltage. Okay, so that's the idea. That's the idea of passive sign convention, and I'm going to expand that a little bit more. Okay, just the notion of what is positive and what is negative. You will see me using that over and over again in multitude of different contexts. Okay, here when you go from terminal 1 to terminal 2, terminal 1 is at a higher potential and terminal 2 is negative, shown with a negative sign, so it's at a negative potential. So what we say is voltage is dropping from terminal 1 to terminal 2. Okay, on the other hand, you could even say voltage is raising from terminal 2 to terminal 1. Okay, very simple idea. If you have to climb down a mountain from a potential, from a higher potential to a lower potential, if you were to come down, you are losing your potential energy. On the other hand, if you're going in the opposite direction, you're gaining potential energy. Both of these mean the same thing, right? Both of them mean that one is at a higher potential and the other is at a lower potential. Okay, so voltage is dropping from a positive terminal to a negative terminal is the same as saying voltage is raising from a negative potential, negative terminal 2 to a positive terminal 1. Okay, again, passive sign convention means when the direction of the current is from positive terminal to the negative terminal, then voltage and current, they're both related with a positive sign. Okay, and we are going to explore this and expand on this in the problems and power and energy power relationship.